Now, we already have this reminder 1 and the reminder 2. How much is the square root? What does it equal to? Let me write it here on the side a different color. The square root of x to the 6th, what does it equal to when x approaches negative infinity?
What's the absolute value of x?
Exactly. The absolute value of x to the 3rd, excellent, which is when x approaches negative infinity. Very good. Brilliant.
0.
We're talking about infinities here. We can...
Infinity?
So let's go back to the reminder.
Oh, as x approaches negative infinity, approaches negative infinity.
Let's go to the reminder. The absolute value of x equals x when x is greater than or equal to 0. The absolute value of x is negative x when x is less than 0. Anyone?
Is it plus or minus infinity? It's only minus.
Okay, minus what?
Minus infinity.
We're not applying the limit. I'm not applying the...
Negative x.
From x cubed, I cannot have negative x, but I can have negative x to the...
Cubed.
Very good. So this is the absolute value of x to the 3rd. This will be x to the 3rd if x is greater than or equal to 0. Will it be negative x to the 3rd if x is less than 0? So if I have a power here, 3 and 3 is the same thing. The formal definition is the same. So again, I'm not applying the limit. I'm only indicated that x is a negative number. So therefore, I need negative x cubed. That's all I was saying. Good. So now, this will get replaced by negative x cubed with minus in front. Good. So I'm back here. So limit as x approaches negative infinity from x to the 3rd, the square root of 4 plus 1 over x to the 6th, everything over x to the 3rd, 1 minus 2 over x cubed. And now it becomes apparent what I'm going to do next. And that is?
Get rid of the x cubed.
I worked so hard for it. That was my target. And now you will tell me where this is going when x approaches negative infinity and where this is going. And now the limit operator goes away because I'm applying it. By showing this, I'm applying the limit operator. Where is this going?
0.
Perfect. Where is this going?
Also 0.
Good. And the limit finally is?
Square root of 4, 1.
Which is?
2.
Which means?
That's a horizontal asymptote.
But for sure, guaranteed at negative infinity only. How come? I used negative infinity to simplify this. If I hadn't used the negative infinity, but I had to, then it would have been on both sides. But it's not on both sides. It's only at negative infinity. Any questions?
Professor, where'd you get 2 from again? Sorry.
The square root of 4 is 2 over 1 is 2. There's nothing else left. The numerator is the square root of 4, which is 2, and there is nothing else left here but 1.
And I just want to double check when you put substituted, or when you simplified the x3 back into the equation, it was negative, and then when you put that in there, it changed the whole thing to positive, right?
The sign, because normally the sign gets connected to the numerator. So if this is negative x cubed with negative in front, will be positive. So I don't have to carry that again.
Yeah, okay, that's what I thought.
Yes, yes, perfect. Yeah.
Thank you.
Thank you. Anyone else? Okay, so let's go back and share. I would like to move on, so let's do one more and then we can come back to, I'd like to definitely look at an exponential. And
I have an exponential that has an indeterminate case.
so yeah, so also here's the third interdeterminate case, so let's look at 30. And which one did you have in mind, 10? Which one?
Oh, I didn't have a specific one in mind. It's just if an exponential has an indeterminate case, that would be good.
Yeah, they're all pretty much indeterminate. So I will also,
38.
yeah, 38.
That
Okay,
was fun.
30 and 38. Very good. So let me copy 30. Where is 30? Okay, here it is. So limit as x approaches negative infinity from the square root of 4x squared plus 3x plus 2x. And then I'll come back. What was the other one? We said 38. Let me copy it here so I don't have to do this again. So limit as x approaches infinity, e to 3x minus e to negative 3x over e to 3x plus e to negative 3x. So you understand that if you start working on homework right away and say, oh, I understood this, and you do not redo the problems we did in class, you're going to stumble from the potentially, I hope not, but it's potentially you're going to stumble from the first problem you try. So that's why we do everything so slowly so everyone can keep up. Okay, enough of that. I know I talk too much. Sorry about that. Okay, so let's take a look at this. I copied again because I don't have enough room. So the square root of 4x squared plus 3x plus 2x. Okay, what is the first thing we need to do? Anyone?
Insert infinity into the equation.
Say it again.
Insert infinity into the equation.
Yes, negative infinity. Very good. Great job. Thank you. So where is this going?
Towards infinity.
Very good. Where is this going?
Towards infinity.
Careful.
Towards negative infinity.
Right. Yeah. So infinity minus infinity is an indeterminate case.
Wait, why would it be going towards negative infinity? If we're multiplying infinity twice by itself.
Say it again.
Why would it be negative infinity? If we're multiplying infinity by 2, theoretically, shouldn't it be going towards infinity?
But you cannot multiply infinity. You have to multiply negative infinity. That's what the limit is saying.
Not squaring it.
Yeah, but if you're still multiplying 2 negative. Oh, I'm being stupid right now. I'm sorry. I see.
Is that okay?
I see my mistake.
No worries. So we know 3 indeterminate cases so far. Again, what does indeterminate mean? We have no clue what the answer is. If we have a number not 0 over 0, this is undefined. This does not exist. And we like a fancy word, undefined. But an indeterminate case can be anything. We have no clue. That's what it means. No clue what we come up with. Okay? And we have 4 more to look at. Okay, so what do we need to do? Anyone? We looked at a limit like this, maybe not. I did this part, I don't remember exactly.
Would you attempt to isolate the infinities to get rid of them so you just have real numbers?
Nope, something else that we should always think. So that's something else that I need to refresh your memory and say remember. To think about. Anyone has any idea what we could do in this case? For expressions with radicals, we think of and that should always be in the back of our minds as a potential option. Anyone?
Was it the possibility of it being 0 over 0?
You have an idea, but so then what do I have to do then? I think you're on the right track. The process is called
Rationalization?
rationalizing. Always, please remember this. Whenever we see radicals, we should always think of the process called rationalizing. I know this could be confusing because normally we say rationalize the denominator. Where is the denominator here? Well, sometimes we have to rationalize the numerator. Good. What do I rationalize it by? And because I'm lazy, I'm going to write it here. That's what lazy people do. Can anyone give us what do we rationalize this quantity by?
You rationalize it by its conjugate.
Thank you very much. So please remember, that's another key word, using the conjugate. Who said that?
Oh.
Thank you, Gabriel. Thank you. Yes, the conjugate. Can anyone give us the conjugate of this expression?
It's going to be the same thing except minus 2x.
That's it. So the square root minus 2x, it has to be top and bottom, the square root minus 2x. So this is 4x squared plus 3x. The minus, because I have the plus. If this were minus, then I would have used plus and plus. Remember, this is 1. All this fraction is 1. So I'm not changing anything. Multiplication by 1 will never change anything. The limit operator does not get dropped. Limit as x approaches negative infinity. I'm going to write the denominator, and somebody needs to give us the numerator, please.
It's going to be 4x squared plus 3 minus 2x squared.
Minus. You're very close, Mark. Thank you. Minus 4x squared. Thank you very much. Was it Leonardo?
Oh, that was Gabriel.
Gabriel. Thank you. Perfect. What next? Any questions?
Terms on the top.
Yes, these two go away. Great job. The numerator is nice. It's just one term. I cannot do anything to it. But let's focus now on the denominator. What is the degree under the square root?
Is it 2?
Good. So what do I factor out under the square root still?
X squared.
Good. Can anyone give us the quantity? Remember, you can factor out x squared from anything you can think of, anything you want.
Plus 3x over x.
Plus 3 over x. Because x squared times x will be x, and so that I can get the 3x. Is that okay?
Yes.
Perfect. So now, this is the square root of a product. What do I need to do next? What did we do on the previous problem?
Separate them into radical x squared and then the radical 4 plus.
Very good. Thank you very much. Who was that?
Jordan.
Jordan. Thank you. So now, since we already know that I have to write the square root of x squared, maybe I should write it. Let me write it. So now, can anyone give us what this is equal to?
So it's going to be plus or minus x.
No, because x does not approach as plus or minus negative infinity, but specifically, is that clear? I'm told exactly where it's going. It doesn't go to both ways. So then what is this equal to?
Negative x.
Excellent, brilliant, thank you. Only negative x because of this. Great job. What is the common factor in the denominator, please? Josh, will you tell us what is the common factor in the denominator?
Can we take out negative 3x? Oh, no, we can take out just 3x. Oh, just x, okay.
The denominator. We cannot combine anything. So these are two terms. This is one term and this is the other. And they both have negative x in common. What is left in parentheses?
Square root of 4 plus 3x minus
3 over x.
3 over x minus x.
Minus 2. I mean plus 2.
Very good. Brilliant. Thank you. Okay, I know you know what I'm going to do next. Don't torture me. Just tell me what.
Cancel out one of the x's.
Now I can drop the limit operator because I'm applying it. Where is this going?
0.
Good. So the numerator is going where?
Three.
Good. Where is the denominator going?
2. 4. 4.
Negative 4.
Negative 4.
So the answer is negative 3 over 4, which means
Horizontal asymptote and negative 3 over 4.
negative 3 over 4 is a horizontal asymptote at negative infinity categorically, definitely, only. Why? I used it. I used it to simplify this into negative x. If I hadn't used it, I would have said at both ends, plus or minus, everywhere. But I used it, so okay. So I promised one more here. Let's work on this one, and then I'd like to finish with one more problem. If I have time, what is the time? As I said, okay.
It's 38.
38. Okay, in 7 minutes, hopefully we can finish that. Yes, this section is longer and more involving.